Good morning to all students. Our today's topic is acid chlorides. We have already started the chapter acid derivatives. Acid chlorides are one of the acid derivatives in which hydroxyl group of carboxylic acid has been replaced by hydrogen atoms as represented by X. Good morning to students. Our today's topic is acid chlorides. Acid chlorides are one of the acid derivatives. We have already started the topic acid derivatives. In case of acid chlorides, hydroxyl group of acid is replaced by any of the halogen atom and represented by X. But in this topic, we will study acid chlorides where X is the chlorine. Here, R group in the structure of acid chloride may be any alkyl group or it may be any aryl group. Now, nomenclature of acid chloride. When we do IUPAC naming of acid chlorides, then terminal IC acid term is replaced by the suffix "-il chloride". So we will replace IC in the acid name with YL when doing naming of acid chlorides. For example, this formyl chloride. The IUPAC name of this formyl chloride is methanol chloride. Similarly, the IUPAC name of acetyl chloride is ethanol chloride. So in this way, we will do IUPAC naming of acid chlorides by replacing of ic acid term with "-il chloride". Next topic is preparation of acid chlorides. We can prepare acid chlorides from the carboxylic acid by reaction with the phosphorus pentachloride, phosphorus trichloride and thionyl chloride. In all cases, we get acid chlorides as a product. The reaction with thionyl chloride is a better reaction because all other byproducts are in gaseous form, can easily leave and we get pure benzoyl chloride in case of preparation from the benzoic acid. Second method is from carboxylic acid salts. Acid chlorides can also be prepared by distillation of salts of carboxylic acid with phosphorus trichloride, sulfuryl chloride or phosphorus oxychloride. So in this case, we also get acid chlorides. So next is physical properties of acid chlorides. First is physical state or smell, etc. The lower members of acid chlorides are colorless boiling liquids, while the higher member, as the number of carbon atom increases, these become low melting solids with pungent and irritating smell. These acid chlorides fume in air due to formation of hydrochloric acid by hydrolysis. So these acid chlorides in reaction with air, they form a hydrochloric acid. So that's why they fume in the presence of air. These acid chlorides are readily soluble in most of the common organic solvents like ether, benzene, chloroform, etc. The boiling point of acid chlorides are lower than those of parent acid, even though they have greater molecular masses. This is because in case of carboxylic acid, there is hydrogen bonding, but in case of acyl chlorides, they do not form intermolecular hydrogen bonds. For example, ethanoic acid boils at 391 Kelvin, while ethanoyl chloride it boils at lower temperature, that is 324 Kelvin. Next topic is chemical properties. Acid chlorides are most reactive of all of the acid derivatives because chlorine atom has a strong electron withdrawing inductive effect and weak electron donating resonance effect. So chlorine has both minus I effect and weak plus R effect. As a result, both aliphatic and aromatic acyl chlorides readily undergo number of nucleophilic acyl substitution reaction in which Cl group is replaced by other nucleophile even it reacts with the weak nucleophile. If we compare aliphatic and aromatic acid chlorides, aromatic acyl chlorides are much less reactive than aliphatic acyl chlorides. This is because electron donating effect of benzene ring. This benzene ring make them less reactive because the electron deficiency of aromatic acyl carbon is there is a positive charge on the carbonyl carbon in case when aryl group is attached to this carbon, electron deficiency decreases. First reaction is nucleophilic acyl substitution reaction. In this we will discuss hydrolysis. With hydrolysis, these acid chlorides converts into their parent carboxylic acid, while lower aliphatic acid chlorides react violently with water at room temperature, but aromatic acids react only slowly because they are less reactive as compared to aliphatic acid chlorides. The mechanism of this reaction is this water molecule behaves as nucleophile because oxygen contains lone pair, so it attacks on carbonyl carbon, which is electron deficient because it attaches to more electronegative carbon which possesses a delta negative charge. So this oxygen attracts electrons of this double bond towards itself and water attacks on the carbon of carbonyl group. Then we get this addition product. Then by loss of proton from this oxygen we get this type of compound. Then by rearrangement of electrons and by removal of Cl group we get carboxylic acid. Another reaction is alcoholysis, in which these acid chlorides reacts with the alcohol and form esters. This reaction is usually carried out in presence of base pyridine. This alcoholysis is carried out in presence of pyridine because in this reaction there is formation of HCl. So this pyridine, this base, helps to remove HCl liberator during this reaction. The reaction of aromatic acid chloride with the alcohol or phenol usually carried out in presence of bases like aqueous sodium hydroxide or pyridine, and the reaction of this aromatic acyl chloride like benzoyl chloride with alcohol or phenol, it may be alcohol, it may be phenol, in presence of aqueous sodium hydroxide or pyridine, giving rise to these esters known as shortened Bowman reactions. The mechanism is same as of the hydrolysis. Here alcohol molecule behaves as a nucleophile. The oxygen of alcohol attacks on carbonyl carbon and form this addition product. Then by loss of a proton from this oxygen, it gives rise to this type of compound. By then a rearrangement of electrons, and by loss of chlorine we get esters. Then third reaction is ammonolysis, means reaction with the ammonia or amines. So in this type of reaction, acid chloride reacts with the ammonia or primary or secondary amine, and we get amides. In this case, one equivalent of acid chloride reacts with one equivalent of base, giving rise to 50% yield of amide. But half of the quantity of this ammonia or amine reacts converts into non-nucleophilic salts. So it attaches to Cl negative eliminated from the acid chlorides. Therefore, a cheap base such as pyridine is added during this reaction to remove the HCl formed. Otherwise, we have to use a double amount of ammonia or primary or secondary amine. This reaction of aromatic acid chlorides with amines usually carried out in presence of aqueous sodium hydroxide and is also known as Schotten-Bowman reaction. And mechanism of this reaction: ammonia molecule behave as nucleophile, as in case of alcohol and water. So lone pair on the nitrogen attacks on carbonyl carbon. Then this carbon oxygen pi bond shift toward pi bond electron shift toward oxygen. We get this addition product. Then by loss of proton and by rearrangement of electrons and by removal of chlorine, we get amide. Further, these acid chlorides reacts with the carboxylic acid in presence of pyridine, giving rise to acid anhydrides. All of the above reactions with the ammonia, alcohol, water or acids are known as acylation reaction, because in all these reactions, hydrogen in the case of water and alcohol, phenol, ammonia, amine, carboxylic acid is replaced by acyl group from the acid chloride. So these acid chlorides are regarded as acylating reagent. When acetyl chloride is used, it is acetylating reagent. It is very good acetylating reagent. And benzoyl chloride is used as good benzoylating reagent. There are some other reactions of acid chloride. So very important reaction is the reduction to aldehyde, Rosenmund's reduction. In this reaction, the acid chloride is reduced with the hydrogen in presence of palladium spotted over barium sulfate and partially poisoned by sulfur or quinoline, giving rise to aldehydes. Benzyl chloride, we get benzaldehyde. In this case, sulfur or quinoline helps to reduce the activity of catalyst and stop the reaction at the aldehyde stage. This reaction is known as Rosenmund reduction, and this reaction is extremely useful because other reducible groups such as nitro groups or carbon-carbon double bond present in the acid chloride are not reduced during this reaction. These groups remain as such intact during this reduction reaction. So this reaction is very important when we have to prepare aldehydes from acid chlorides. Then next, these acid chlorides on reaction with the lithium aluminum hydride or sodium borohydride followed by hydrolysis converts into primary alcohol. So we can say alcohols are produced, primary alcohols are produced by reaction of acid chlorides with these reagents. Then these acid chlorides may react with the organocadmium compounds and converted into ketones. So this reaction shows the reaction of acid chloride with dialkyl or diacadmium, or these may react with lithium dialkyl cuprate. In presence of these conditions, we get a ketone. On the other side, Grignard reagent and organolithium compounds also react with acid chloride, but in these cases reactions does not stop at a ketone stage because these reagents are more reactive as compared to organocadmium compounds. So in these cases, Grignard reagent and alkyl lithium, we get a tertiary alcohol rather than ketone. Reaction doesn't stop at the ketone stage. We get a tertiary alcohol in excess of the presence of Grignard reagent and alkyl lithium compound. But in case of organocadmium compound, we get ketone from the acid chlorides. Then Friedel-Crafts acylation. Acid chlorides reacts with the benzene in presence of anhydrous aluminum trichloride. We get aromatic ketones. Halogenation of alkyl group. In case of acid chlorides which have alpha hydrogens, they undergo halogenation to form alpha halo acid chlorides. So this chlorine replaces the hydrogens at the alpha position of acid chloride. In presence of small amount of red phosphorus, they form alpha halo, alpha chloro in this case, alpha chloroacid chlorides. And last is electrophilic substitution reactions of aromatic ring. In case of aromatic acid chlorides, these compounds undergo electrophilic substitution reactions of the benzene ring present in these aromatic acid chlorides, such as halogenation, nitration, sulfonation. And these reactions of benzene we have already studied in B.Sc 1. So for the acid chloride, this COCl group is electron withdrawing group. So it deactivates the benzene ring and directs the incoming to second substituent at meta position. So this is all about acid chlorides. Thank you.